The Permian mass extinction was the largest extinction event in Earth's history, and it happened about 252 million years ago, give or take. Doesn't ring any bells? It's the reason we're all here today, so it's kind of important. Just as the extinction event that wiped out the dinosaurs 65 million years ago, many geologists believe a huge rock flying into the Earth may have caused the Permian extinction. National Geographic reports that scientists have found rubble and craters from the right time period in Australia, and that debris contains a very rare hunk of shocked quartz, which is different from regular quartz on a microscopic level and only forms during asteroid events. These fragments have also been found in Antarctica, which was, at the time of the event, in the same general area of the supercontinent Pangaea as Australia. For an idea about just how far removed from our modern era this was, the landmass of Pangaea was just starting to split up, a world-changing event that the Geological Society said happened about 250 million years ago. However, it's also believed that if an asteroid did in fact strike Earth, it most likely barreled into the ocean and kicked up the shocked quartz and the resulting watery explosion. However, if this is the case, the event left us no underwater clues to observe today, since Earth Archives notes that the ocean floor gets a tectonic makeover every 200 million years. Scientists also think the Big Blue Sea could have had a hand in this mass murder. How? Andrew Knoll, a Harvard University paleobiologist, told National Geographic that it's not clear. Still, Knoll suggests something massive disturbed the planet's marine ecosystem, and the results could have turned deadly. The disturbance, he says, could have stirred up the excrement of marine animals, which would have released a ton of bicarbonate into the upper oceans. It could have been such a drastic event that he suggests the seas may have bubbled as a result. Imagine the fizz that comes with pouring soda into a glass, and it's possible that's what happened. A large percentage of oceanic life would have struggled to breathe and eventually fallen asleep. Forever. Knoll says, perhaps the Permian ended with a whimper and not a bang. So how would that have mattered to life on land? With enough carbon dioxide floating up into the atmosphere, life on land would have had to endure the adverse effects of global warming with the sudden addition of so much greenhouse gas. Scientists have also found a very likely accomplice for the mass extinction, and it's located in Siberia. It's a massive field of volcanic rock, a reminder of extreme volcanic activity in eons past. In the late Permian, multiple volcanoes started erupting in one of the largest volcanic events in Earth's history. This map outlines just how large an area it was, and essentially, it was a massive field of volcanoes called the Siberian Traps. The volcanoes also released tons of ash and greenhouse gases into the atmosphere, creating an environment where things would inevitably get uncomfortably hot. According to Stanford, the eruptions could have raised the temperatures of the oceans by 20 degrees, which caused the oxygen levels to plummet by 80%. On top of that, the ash from the volcanoes could have blocked out the sun for a prolonged period of time, robbing plants of their ability to photosynthesize, and ultimately leading to the collapse of the entire food chain. Most likely, it wasn't just one event to blame for the Permian mass extinction, and it was more of a cocktail of catastrophes. But one thing is for certain. Whatever happened, research from Imperial College London suggests that it also caused the most terrifying rain showers to fall over the entire planet. Scientists have confirmed that large amounts of acid rain poured over Pangaea during this apocalyptic extinction event, and they did it by finding the compound vanillin, a byproduct of these menacing drizzles in the Dolomite Mountains in Italy. Now, the clearest source for the acid rain would be the volcanic eruptions in Siberia. This is because the gas that plumes into the atmosphere during these events is thick enough to block out sunlight for long enough to make temperatures drop. National Geographic describes the scenario as being the perfect conditions for kickstarting the cascade of acid rain and snow.
But the storm clouds gathering east of Eden suggested that the first thunderstorm was on its way, and it was going to be a big one.
Surprisingly, this event was more significant for what it did to the plants than what it did to the animals, at least at first. The acid rain would have made the ground extremely acidic. This would have made it impossible for flora to thrive, cutting out the bottom of the food chain and eventually impacting everything. Let's put things in perspective here. Paul Rene, a geologist from the Berkeley Geochronology Center, noted, in 1783, a volcano called Laki erupted in Iceland. Within a year, global temperatures dropped almost 2 degrees. Imagine a Laki erupting every year for hundreds of thousands of years. The world as we know it today, relatively speaking of course, has seen occasional volcanic eruptions, but you have to consider that the eruptions in Siberia are estimated to have lasted for hundreds of thousands of years. Study of the sediment layers left behind has led a team of researchers from the universities of Geneva and Zurich to conclude that particles from this historic eruption blocked out the sun for so long that it sent Earth into an 80,000-year ice age. Evidence of the Ice Age has been found in samples taken from rivers in China, which showed ash beds and a huge decrease in marine life. This can only be explained by lower ocean levels. The thinking is that as glaciers formed in the oceans, the sea level lowered and life became impossible for creatures who lived in the receding shallows. If not already apparent, life under the sea bore the biggest brunt of the apocalypse. Britannica says that more than 95% of marine life died out, most on account of low oxygen levels. Conditions were evidently more severe down in the tropics, but life there seems to have adapted more readily than creatures who lived closer to the poles. Researchers from Stanford believe that this was probably due to tropical species having the ability to pick up and swim towards temperatures that were closer to their original heat preferences, whereas marine life that lived in colder areas of the world were already struggling as their waters grew warmer. Scientists estimate that around 70% of life on land shuffled off this mortal coil during the Great Dying, with much of it succumbing to a lack of food. How do scientists even know this? Fossil evidence is next to non-existent, but that's actually a clue in itself. Fossils that predate the mass extinction have shown that forest and terrestrial creatures were thriving before the savage event, or combination of events, took place. Thereafter, most of them disappear. National Geographic explains the phenomenon by saying that suddenly the fossil record became about as species-rich as a cornfield. Now, there's still some disagreement about exactly how long the mass extinction took, but most scientists agree that it didn't take millions of years to unfold into a total apocalypse. How do they know this? National Geographic says that the fossil record doesn't show a gradual decline of life, but rather a clear-cut boundary of when most living things vanished. Now, that isn't to say that the conditions leading up to the extinction didn't take some time, give or take a few million years. But as far as when most marine animals, terrestrial species, and plants died out, different scientists, including researchers from Stanford University and MIT, have estimated that it may have taken between a few centuries to 200,000 years. In the grand scheme of things, that's no time at all. Not all life had a hard time when the majority of Earth's living things died out. Quite the contrary in some cases. Fungus thrived, and in the rock layers before the Permian Extinction, National Geographic says that researchers from the University of Utrecht have found tons of fossils that left a legacy of a wildly diverse ecosystem. Moving up in the sedimentary layers, all signs of pollen and plant particles pretty much vanished and are replaced with fossilized fungi that once thrived in the dead landscape. This decaying, rot-filled environment became only suitable for scavengers, which is why scientists believe smaller animals tended to do better than larger ones during the end of the Permian. All this rotten mold may have had the Siberian eruptions to partially thank for their infiltration. Nickel helps certain methane-producing microbes thrive, and as Britannica notes, it's plentiful during volcanic events. So, some scientists think that not only were the eruptions releasing a huge amount of greenhouse gases, but they also helped fuel microorganisms that pump out noxious methane too. It was essentially the perfect storm. Before most of life was destroyed, terrestrial animals looked little like the creatures we're familiar with today. Earth Archive says that most of the land animals belong to one or two groups, the mammalian synapsids or the reptilian sauropsids. Surprisingly, there was one extremely important critter that did make it out of Earth's biggest apocalypse, and it doesn't appear to fully belong to either group. This animal looked like a cross between a lizard and a pig. Meet the humble Lystrosaurus.
Chorizo tacos.
Are you saying chorizo tacos?
Don't play around because I'm super hungry.
National Geographic says this 3-foot-long animal most likely made it out alive for a few reasons, starting with big lungs that allowed it to breathe under super difficult conditions. It also foraged for food underground, so it's likely their food situation wasn't as desperate as that of many other creatures. Remnants found of this reptile pig also show its ability to take long strolls to the far reaches of Pangaea. By migrating to ecosystems that would support its survival, the Lystrosaurus is undoubtedly a species we have to thank for contributing to the repopulation of the planet, particularly among mammals. There's another footnote to this too. The Lystrosaurus also made a major contribution to geological research, as fossils found in Africa, China, and Antarctica laid the foundation for the theory about plate tectonics, or how our world used to look and how it became what it is today. In a time when carbon dioxide ruled the atmosphere, National Geographic suggests that certain reptilian-like species were able to strut into the Triassic thanks to a few helpful advantages. Like the lizards we find today, early creatures like the rat-sized Congonophan were well suited to breathing in low-oxygen environments. While one lung pumped, the other absorbed oxygen. This was a great advantage to have during a time when oxygen was in devastatingly short supply, and it's probably why reptiles did so much better than their more mammalian-esque counterparts. There was still quite a bit of evolutionary work to be done before these tiny creatures could become the glamorous dinosaurs we all admire today. Virginia Museum of Natural History paleontologist Adam Pritchard says that it didn't happen overnight. The development of the Archosaurus, the earliest of these reptiles, took between 5 and 10 million years. Even that was just the beginning, and it was a long time before they became the most menacing creatures the planet has ever seen. According to the fossil record, planetary temperatures from the beginning of this period were very similar to what we enjoy today. The Permian mass extinction was initiated by greenhouse gases, and it's easy to draw an immediate parallel to the situation we found ourselves in today. Listen to the science, and it's clear that our planet is in a dire state. In our 21st century case, though, society is the volcano spewing loads of poisonous fumes into our delicate atmosphere on a daily basis.
I love the smell of napalm in the morning.
According to Stanford, projections for Earth's future temperatures show that we'll have heated the oceans to 20% of what they were in the late Permian by 2100 and up to 50% by 2300. That is some serious food for thought, especially since we can see how this whole thing ended up going the last time. Estimates like these hint at a similar situation we may be dealing with in the very near future. The question is, who's going to make it through? Will humans get set back thousands or even millions of years? From a certain perspective, that might not be the worst thing. Maybe if we get a do-over, we'll get it right next time. Check out one of our newest videos right here. Plus, even more Grunge videos about history's most unsettling events are coming soon. Subscribe to our YouTube channel and hit the bell so you don't miss a single one.